Hello. In continuation with our topic energy in the environment, and we were discussing about petroleum oil and various other sources of energy. Shale oil, as we had discussed, is the oil which is produced from kerogen, which is an organic material present in shale rocks, and there are certain disadvantages associated with shale oil, but still it is being used in certain areas of US as the amount of shale rocks is quite large in those areas. Apart from petroleum oil and shale oil, another kind of oil which is obtained is from algae, is called algal oil. So, the algae, which are photosynthetic organisms, they are found in water bodies. The algae processed in the refineries can produce gasoline, diesel and also jet fuel. However, its production is not very economical, and the below picture shows a spread of green algae on a water body, which is further extracted to produce these kind of energy sources. These are the steps involved in algal oil extraction from algae which is growing on the surface of water bodies. So, first of all, algae is grown in open ponds, and this algae is grown specifically for the production of, using it in the production of energy. After that, algae is harvested using filters. Then the algae which is harvested is separated from the water. After that, algal oil is extracted with solvents like hexane, and then this algal oil is processed in refineries to obtain gasoline. Oil production can also be caused from tar sands. Tar sands are large deposits of bitumen. Bitumen, as we know, is a form of coal. This is a kind of a very heavy oil. This bitumen, which is an oil, the oil sands are actually very naturally existing sandstones, which consist of a mixture of sand, clay and water, which are saturated with extremely dense form of petroleum, and the below picture shows the tar sand, which is very thick and black in color. Apart from this, vegetable oil can be extracted from plants, and plants crops can give rise to biomethane and biodiesel. That means these two fuels, biomethane and biodiesel, can be extracted from plant crops. These are the sources of oils. Like biomethane is obtained from sugar containing plants, and biodiesel is obtained from oil rich plants. Now, this is a composition of a natural gas. Natural gas consists of methane, ethane and propane and butane in comparatively smaller quantities. That is, the major quantity is of methane and ethane in natural gas. Energy can also be obtained from natural gas. Just like petroleum, natural gas is obtained from the decomposition of organic matter trapped in layers of sedimentary rocks. The largest natural gas reserves are in Russia and the Middle East. In India, however, natural gas reserves are found in Bombay High and Gujarat. The energy from natural gas is a clean form of energy because natural gas is a relatively clean fuel obtained in the form of CNG, which is compressed natural gas, and LPG, which is liquefied petroleum gas. The pollution caused by natural gas combustion is much less than that by petrol or by diesel. There are no sulfur related emissions from natural gas, and sulfur related emissions include the emission of sulfur dioxide, sulfur trioxide, and so on. Natural gas can also be used for the generation of electricity. Some amount of hydrogen can be added to natural gas to increase its calorific value. Now, up till now we have discussed a number of energy sources which are renewable as well as non-renewable energy sources. There is another important energy source which is obtained from the nucleus of an atom, and such kind of energy is termed as nuclear energy. So, non-renewable energy resources, they are being constantly depleted, and there are finite resources and they are being depleted at a rate which is faster than the rate at which they are being replenished. Burning of fossil fuels also leads to global warming. Thus is the need for an alternative source of energy. The development of an atomic reactor is a great step towards generation of nuclear energy. So, there is a lot of energy which is stored in an atom, and it is energy released in a nuclear reaction. So, nuclear reaction is of two kinds. One is nuclear fission and the other one is nuclear fusion. Now, the total mass of products in a nuclear reaction is less than the total mass of the reactants, implying that there is some mass which is lost in the reaction, which is eventually converted into energy. That means, if the mass of the products is less than the mass of the reactants, then definitely there is a loss in the mass, and that is actually converted into energy. So, according to the Einstein's equation, E is equal to mc square, where we know E is the energy, m is the mass, and c is the velocity of light. The velocity of light is very high, hence small loss of mass is converted into large amounts of energy, because as the equation shows, E is equal to mc square, there is a direct relation between mass, velocity and energy. So, small loss of mass is converted into large amounts of energy. The energy obtained in a nuclear reaction is thus much higher as compared to the energy obtained from the burning of fossil fuels and various other sources of energy. Depicting a nuclear fission reaction, this phenomenon, which was discovered by Otto Hahn, a German scientist, where a neutron strikes a radioactive uranium-235 unit, ultimately giving more of radioactive uranium and finally giving many more neutrons and fission products, including krypton and barium. These are all radioactive fission products. So, when uranium atoms are bombarded with neutrons, as we have already seen in the figure. The atoms break to form nuclei of lighter elements, emitting more neutrons simultaneously along with a large amount of energy. As we can see over here, neutron is bombarding uranium, which is producing lighter elements which are radioactive, and many more neutrons. The neutrons so released further bombard more uranium atoms, thus giving rise to a chain reaction. This process is the underlying principle of nuclear bombs. The fission of radioactive uranium-235 occurs as follows, as given in the equation, where neutron bombards uranium-235. Uranium-235 is the radioactive isotope of uranium, giving the radioactive isotope barium-141, krypton-92 and 3 neutrons. So, as we can see that one neutron was bombarding uranium-235 and it is producing 3 neutrons from one reaction and 3 neutrons from the second reaction. That means a total of 6 neutrons. And in the second reaction, as it is shown, strontium 90, which is again a radioactive isotope of strontium, xenon 143, again a radioactive isotope of xenon, and neutrons, 3 neutrons are produced. Considering nuclear power plants, these are the power plants where nuclear fission reactions are carried out to produce energy. So, two types of reactors are used in nuclear power plants. These are boiling water reactors and pressurized water reactors. Both these reactors utilize uranium-235 as a fuel, where controlled fission of uranium-235 in the reactor core produces heat and energy. So, controlled fission needs to be carried out, because otherwise it is a chain reaction which is uncontrolled chain reaction. And if a chain reaction is not controlled, it may lead to disastrous outcomes. So, a controlled fission of uranium-235 needs to be carried out in nuclear power plants. The interior of the core of the nuclear reactor is shielded with layers of concrete and iron or steel to protect the workers from radioactive particles. Picture showing boiling water reactor on the left hand side and the pressurized water reactor on the right hand side. So, these two are the kind of water reactors, or to be precise, nuclear reactors from which energy is produced. Since uranium-235 is not very abundant, this form of radioactive isotope is not very abundant. Hence, it needs to be increased by enrichment. In a fuel rod, uranium-235 and uranium-239 are present, out of which uranium-239 is not radioactive. Hence, it does not undergo fission. As the reaction proceeds, the concentration of uranium-235 starts decreasing, and gradually the fission process slows down as the fission products are bombarded with more neutrons in the chain reaction. Both BWR and PWR reactors work on the above principle. The water which is flowing through the core in BWR, that is boiling water reactor power plant, gets converted into steam, which is further used to run a turbine for the generation of electricity. Now, there are control rods in the nuclear reactor which are made of cadmium. The role of cadmium is to absorb excess neutrons and hence control the fission process. There are certain advantages which are linked to the use of nuclear fuel. The formation of small amounts of solid waste in a nuclear reactor is a major advantage of producing energy or electricity from a nuclear reactor using nuclear fuel. The production of large amounts of energy take place in a nuclear fission reaction which can be further harnessed. And apart from this, no harmful gas and particulate emission takes place in this kind of a reaction. However, there are certain disadvantages also linked to the use of nuclear fuel. Nuclear fuel is an expensive mode of operation, or nuclear reactors require high costs for setting up and further operation. There is a large capital investment which is required for running a nuclear power plant. The disposal of radioactive waste is also very difficult. Radiation hazards are involved during the working of the reactor and after that also when disposal of the waste is required. Then another kind of nuclear reaction is the nuclear fusion reaction, as the picture shows, wherein fusion of nuclei give a new nucleus releasing a lot of energy. That means three kinds of nuclei or allotropes of hydrogen, tritium, deuterium, helium, they all fuse together along with neutrons and release a lot of energy. So, nuclear fusion is a process by which two lighter nuclei combine, or to be precise, fuse to form a heavier nucleus. This process releases a lot of energy. Now, the mass of products formed in nuclear fusion is less than the sum of the masses of the reactants, and this difference in masses is equal to the energy produced. This is somewhat similar to the nuclear fission process, in which again the mass of the products was less than the mass of the reactants. So, when two nuclei of the hydrogen isotope, which is deuterium, fuse, it results in the formation of a helium nucleus. Again, the picture which is showing the fusion resulting in the formation of helium isotope or nucleus and releasing a lot of energy. So, when two positively charged nuclei react with each other, repulsion occurs between them. However, this repulsion needs to be overcome, which is made possible by making the nuclei collide at very high speeds. So, as we see over here, that when deuterium and tritium, they try to approach each other, both of them have the similar charge, and as we know, similar charges always repel each other. So there is a lot of repulsion energy which is thus created, and to overcome this kind of repulsion, the nuclei need to be collided at very high speeds. The fusion of hydrogen to form helium is a constant process taking place in the sun, which is a source of the sun's energy. As we all know, the source of the sun's energy is nuclear fusion reaction. So, the reactions which are taking place constantly, continuously in the sun are where protons are combining to form deuterium, further combining to form tritium, and these isotopes of helium which are further combining to form more amount of helium and a lot of energy released along with it. Now, this kind of fusion reactions, they are also the underlying principle of a hydrogen bomb. That means the fusion reactions which are taking place in the sun are similar to the fusion reactions which are the underlying principle or the basic principle behind the working or the action of a hydrogen bomb. Now, when these nuclear fission and fusion reactions take place, definitely a lot of pollution can be caused due to the radioactive waste which is produced. The worst possible pollution which can have disastrous effect on humans and animals is due to radioactive sources. Many other sources of energy have their disadvantages, have their effects on humans and animals and vegetation, but the most disastrous effect is caused due to radioactive waste. So, the sources of radioactive pollution include the testing of nuclear devices above the ground. Now, this testing results in nuclear fallout spread in the atmosphere in the form of radioactive cloud. The radioactive dust also falls on the ground, affecting organisms through the food chain. Pollution due to radioactive waste can also be caused due to X-rays. X-rays are highly penetrating and they are used for diagnostic purposes. Their exposure in the body can cause chronic defects in the internal organs. Although X-rays are used for variety of medical purposes, but their overexposure in the body can cause defects, because actually the X-rays are radioactive, formed as a result of radioactive waste, and they penetrate deep inside the organism. Nuclear tests which are carried out before testing a nuclear reactor can also cause a lot of addition to radioactive waste. Radioactive pollution is caused by nuclear tests which have been carried out by various countries. A large number of radionuclides are released in the atmosphere as a result of this. So, as we have just mentioned, that these nuclear tests have been carried out by various countries, generally the developed countries and certain developing countries, because this is termed to be as a show of strength. The use of nuclear weapons is termed to be as a show of strength by many countries to establish their supremacy. But as a result of this, the impact which it is having on the environment, on the organisms, on the plants, vegetation, the organisms on the land or in the sea is drastic. So, the nuclear tests which are carried out, or the nuclear energy which is being produced, is quite effective. A large amount of energy is being produced as a result of these tests, but in turn the environment has to pay a price for this. So, as we have discussed, various sources of energy which include renewable energy sources, non-renewable energy sources, and the major one which is the nuclear energy, which is different from the renewable and non-renewable in terms that it is the most effective kind of an energy source, because it is an energy source where maximum amount of energy is being produced. From renewable and non-renewable energy sources, as we have discussed in our previous lectures, the amount of energies which are produced are comparatively lesser, but the renewable energy sources, which are including solar energy, wind energy and many others, are less polluting, or in fact wind energy or solar energy to be precise cause a minimum amount of pollution. Certain other non-renewable or conventional energy resources, they are causing a lot of pollution in the environment, as we have already discussed about petroleum oil or coal or certain other kind of fossil fuels, those fuels which can be obtained from rocks, the organisms which are existing in the rocks. Then certain renewable sources of energy which are biogas, producing biofuels, leading to minimum kind of pollution. But the major energy source which is there, which is actually a man-made energy source for the use, which is giving a maximum amount of energy, is also causing maximum amount of toxic effect or chronic defects in the environment. So, lot of care needs to be chosen, needs to be done, and the sources need to be utilized judiciously and consciously for the protection of the environment. Thank you.